Before we continue, we are going to do a few examples with you on prime factorization, right? Um, and we need to ask ourselves, I've already shown you one of these things in terms of prime factorization. The big question about what are we doing? The question is, what are we doing? We are factorizing. We are applying the process of factorization, right? And we are not just applying factorization, but we are looking for prime factors. Now remember, what's a prime number? I'm going to give you the definition of a prime number. A prime number is a number that has two distinct factors. Every prime number has two distinct factors, right? Two distinct factors. And so let's look, what does distinct mean? It means it has two different factors. Now, the question is, let's look at the number 2. 2 has 1, 1 can go into 2 perfectly, and 2 can go in there. 3, 1 can go in there, 3 can go in there. The number 4, 1 can go in there, 4 can go in there, but 2 can also go in there perfectly. So if we look at these examples, we say that 2 is a prime number, 3 is a prime number, 4 is not a prime number because it has more than 2 factors. Okay? It has more than 2 factors. In other words, it has more than 2 numbers that can perfectly fit into it. For example, 4 can perfectly go into 4 one time, and 2 can perfectly go into 2 twice. But if you look at the number 5, only 1 can go into it and only 5 can go into it. So it must have only 2 distinct factors, right? 2 distinct factors only, and those factors must be itself and the number 1. Now the big question is 1 a prime number? Is 1 prime? And the answer is no. Okay? The answer to this question is no, because 1, the only number that can go in there is 1. Okay, so as mentioned, the answer is no, because 1 only has 1 factor. It doesn't have 2 distinct factors, right? It only has 1 factor. Only 1 can go into it. And we can't just say only 1 in itself, because 1 is itself. So the number 1 is neither prime nor composite. Okay, so the number 2, for example, this is a prime number, because it only has factors 1 and 2. 3 is a prime number, right? And the number 4 is what we call a composite number. Okay. And so what we really want to do is we want to factorize something. When we factorize something, we say it's equal to something multiplied by something. So for example, if I write the number 6 as a product of 2 and 3, then I say that 2 is a factor of 6 and 3 is another factor of 6. So the aim with prime factorization is to end up with a number that is not written as just the number, but rather the number is written as something where we have something multiplied by something else, and each of these somethings are called factors. In the case of prime factorization, we want to make sure that every little factor that we have is a prime number. Okay, so let's do an example. Let's take a simple one. Let's take the number 26. Now 26 can be written as a product, in other words, something multiplied by something else, a product of primes. So let's ask ourselves, 2 multiplied by what gives me 26? And let me just list the numbers here. The process works like this. You start with 2, then you move to 3, then you move to 5, then you move to 7, then you move to 11, then you move to 13, and so forth. So we start with the first prime number, and we start with 2, and we say 2 times what gives me 26? And the answer is 13. And then we say, okay, is 13 a prime number? And the answer is yes. If the answer is yes, that this is a prime number here, then we stop. Right? And we can say that 26 is equal to 2 multiplied by 13. That is prime and that is prime, so we consider this a product of primes. Let's look at another example, 39. Well, does 2 go into this number? 9 plus 3 is 9 plus 3 is actually 12. So 3 can go in there, but the question is, sorry, we must start with 2. Does 2 go in here? 2 clearly does not go in there, so that's not going to work. So I move to the next prime number, and I see, does 3 go in there? And the answer is 3 does go in there. It goes in there 13 times. And then again, the number 13 is prime, so I can stop, and now I can say that 39 is equal to 3 times 13. And this is considered prime factorized, right? So let's take a little bit more challenging one, and we start again with the first prime number. Let me start with 112. 2 times what gives me 112? That's going to be 50, and that's going to be 6, so it's going to be 56. Then I move again, and I start with the first prime number, and I see can 2 go into this number? And 2 can clearly go in there. So I say 2 multiplied by 28, and can 2 go in there? 2 can go in there again, and so I say 2 times 14, and 14 is 2 multiplied by 7. At this point I can see that I clearly have 7, and therefore this number is also a prime number, and therefore I can stop here. Right? If this number, I only stop on the right hand side when I reach a prime number. Okay, so let's see. This tells me clearly that 112 is equal to 2 times 2 times another 2 times another 2 times 7. Okay, and that's equal to the following. That is 2 to the power of 4 multiplied by 7 to the power of 1. That's the alternative way of writing this using the exponent laws. Okay, so there's your brief background. Let's do another one. Let's use the number 54. And let's start with the number 2. Right, 54. Let's start with the number 2. 2 multiplied by what will give me 54? It's 25 plus 2 is going to give me 27. Is this number a prime number? The answer is no, because 2 can't go in there, but 3 can. So we don't start with 2, but rather we move to 3, and we then get 9. Then we see if 2 can go in here. If 2 can't go in here, we go to the next prime number. So we say 3. 3 can go in there, and that's 3 multiplied by 3. And so now I can say that that is 2 times 3 times 3 times 3. And that's what 54 prime factorizes into. Is equal to 2 multiplied by 3 multiplied by 3 multiplied by 3. 27 times 2 gives me 54, so that's 2 to the power of 1 multiplied by 3 to the power of 3. Okay,